Um, Chat. I think last class I mentioned about the exams and that I think we said the 9th week, but it's going to be the 10th week because of fall break. So for your exams, there's an exam Friday, October 22nd, an exam Friday, November 12th, and then your final exam is December 3rd from 2 to 4:30. The regular exams will be similar to the first one where there's part take home, part in class. The final will probably be all in class though, because it's 2.5 hours. It will probably be in class. Any questions on that? Okay. Um, Chapter 6. A lot of times when we look at a function, we look at total cost, total profit. There's times where you want to know how much it is per item. And so that's what you call average of a function. So if we have a function f of x, to find its average, for average, they put a bar over top of the variable. And then you just take your function and divide by x. This is nice when you have a polynomial. When you have a fraction, it's easier if you multiply by 1 over x. We're dividing by a number is the same as multiplying by its reciprocal. So when I have a fraction, I will use this, but when I have a polynomial, I will use this. And you'll want to know that formula. The cost in dollars for manufacturing a particular DVD is C of x equal to $15,000 plus 6x, where x is the number of DVDs being produced. Find the average cost function and then find the limit as x goes to infinity of it. So first we'll find the average cost function. This is a polynomial, and you just place it over x. So this function gives you total cost, and this one gives you, when you produce so many of them, it gives you the price per item, cost per item. To better understand it, let's find the cost function at 100 and the average cost function at 100. And just plug it into the equations. In the first one, when you plugged in the 100, you got 15,600. This is the total cost. So if we want 100 DVDs produced, it's going to cost $15,600. Now, if you want to find how much it is per DVD, you find that value and divide by 100 because we were producing 100 DVDs. And if we did that, we'd have $156. So this is total cost when 100 are produced. This is the cost per DVD when 100 are produced. Any questions on that? Okay, let's find the limit to infinity of the average cost function. Remember, when we're finding limits to infinity, we look at the degree of the top and the bottom. So what would the degree of the top be? Anyone?
1.
Mm-hmm. Because remember, when there's no exponent on your variable, it's a 1, which means the degree of the bottom is also 1. When the degree of the top and the bottom are the same, it approaches these two values. And so you can just simplify with the largest degree terms. As a large number of DVDs are produced, the cost will approach $6 each. And we're talking about a large number of them, because remember, at 100, the average cost is $156. That dropped a lot. But by doing this calculations, you know that when you're calling companies to produce your DVDs, if you're finding this value that's too high, you should find something around 6. And is there any questions on the difference of C of X and the average cost function and the limit? Okay. Another way of seeing that this is going to 6, we can put y equals, so we're going to use the average cost. 15,000 plus 6x divided by x. And then I'm going to go to my table. You don't have to graph it. Second in table. Notice when I type in 100, we have the 156 that we got here. Now, as this gets larger, 1,000. Just 1,000 dropped down to $21 per DVD. 10,000, 7.5, $7.50 each. 2, 3, 4, 5 zeros. 100,000, We're getting close to that 6. It's getting even closer. Eventually it will round to it. Now notice when I highlight my number, it shows the whole number down here as at least more than it shows in your table. So if I go over to this 6, it's not actually 6. It's just that the amount that will hold here rounds to a 0, so it's 6. So it will get close to 6, but it never reaches it. But as you produce more DVDs, you get closer and closer to $6 each. Any questions on that? So we can take the limit by looking at the degree at top and bottom, or we can plug values that get extremely large. Any questions? So you do want to make sure that you have this marked to memorize for the exam. Section 6.3 is rates of change. And there's two that we look at. First, we look at average rate of change. From A to B. So we're looking at how it changes from one value to another. That's your slope. So you can use f of b minus f of a over b minus a, or you can use y1 minus y2 over x1 minus x2. Either one. Okay, let's try one. If we have y equals x squared plus 2x from x equals 1 to x equals 3. So we want to see how y changes as we go from 1 to 3. A is your smaller value and B is your larger. If you switch them, it's not going to matter. It still works out. But it normally goes from A to B. So it's f of 3 minus f of 1 over 3 minus 1. Now we're plugging in 3 into the equation and then 1. You can write them out. We plugged in 3. We have 3 squared plus 2 times 3 minus, and then f of 1 squared plus 2 times 1. Now this one's not too hard. We can do it in our head. And 3 minus 1 is 2. We can see that this is 9 plus 6, or 15. And this is 1 plus 2, or 3. Another way of doing it, though, especially when there's more to plug in or larger values, you can put the equation under y equals x squared plus 2x. And then second in table, and I'm going to delete what I have there. I want 3 and 1. Notice it's giving you your points, your X and your Y points. So then you can subtract your Y's, subtract your X's, and divide them. But f of 3, this, is 15. So it's 15 minus 1 over 2, which is 14. Wait, 2. Whoops. This should be a 3. It's a 3. over 2, which gives us 6. So you can plug it in and calculate each one individually, or you can put them in y equals, put the equation, go to your table and plug them in. So then it's just 15 minus 3 over 3 minus 2. Is there any questions on that? I don't recommend plugging this all in at once. There's too many careless mistakes that happen. Well, the next one we're going to do is a nice one to just plug in all at once. If y equals e to the x from x equals -2 to x equals 0. It's not much to plug in, so entering it at once is nice. Also, depending on what you're plugging in, it has a lot of decimals, and we don't want to round, so it's nice if you can enter it all at once. This is our A, this is our B. F of 0 minus f of -2 all over 0 minus a -2. E to the 0 minus e to the -2 over 2, because a negative and negative is a positive. 0 plus 2 is 2. Any questions on plugging it in? Okay. Now, if you do want to enter it all at once, let me clear my screen. There we go. The E button, E and natural log are inverses of each other, so they're together. No matter what calculator you have, the natural log and the E will be together. Even if you have natural log and E are inverses, so find your natural log and you'll find your E. The log and base 10 are inverses, so those are always together also. Now to bring it up, I'll show you this calculator first. So here's our E. We have to hit second. Put a parenthesis first if we're going to enter it all at once. So this is the one we're entering. So I put my parenthesis, then for my E, I hit second and the LN button. Notice it puts the exponent up there already, and I just put my 0. But then you have to push the right arrow to come back down. And then minus, bring the E on again. And -2. Make sure you're hitting negative for the 2. So you have to use a negative, not minus. Push the right arrow to come back down, close your parenthesis, and divide by, it was 2 again. It's not always 2. But here's your answer. 4, 3, 2, 3. So that's one way of doing it. If you use the table, you'd plug it in here. E to the X. And then go to your table. And we wanted 0 and -2. E to the 0 is 1, because anything to the 0 power is 1. E to the -2 is this. If you subtract them and divide by 2, you'll get this. So you can plug it in just like we did the other ones. Now on this one, and this is also the case with the TI-83, it doesn't put it up in an exponent, it uses a caret. Oh, I have it up here already. So we would put parenthesis, and then the E is with the natural log right here. So second E. That caret is the same as exponent. 0 minus, bring the E back, -2, close my parenthesis, and divide by 2. So you're going to get the same answer, just looks a little bit different. Any questions on that? Try one more. Let's try y equals the natural log of x from let's do one that's let's go from 1 to 4. This is our A, this is our B. Okay, go ahead and find it. Or the natural log is where the X button was, same button. The natural log of 4, oops, I didn't hit natural log. Natural log of 4, then you have to close your parenthesis, minus natural log of 1, close my parenthesis, and then I divide by 3. You should get 0.462. Any questions on those? So this is telling you how it's changing. As I go from 1 to 4, my Y value changes by 4/10. Same thing on this one. As I go from -2 to 0, Y goes up 0.4 or 4/10. This one, as I go from 1 to 3, it goes up 6. It's going up because all these ended up being positive, which isn't always the case, but any questions on that? Okay. That was the rate of change between two values. There's also instantaneous rate of change. And instantaneous rate of change is the change at one value. So if you were at 10, it's telling you if you went one more, how much y would increase by. Oh, we gotta give you the formula first. The limit as b approaches a of f of b minus f of a over b minus a. But this time, we only have an a value. And if you remember, when we had limits to a number where we had 0 over 0, you have to simplify and then you'll plug a into the equation. So we'll only have one value. That helps you understand that it will be instantaneous. Next class, we'll learn another way of doing it. And then when we get to the next chapter, we'll learn a short way of doing it. But first we have to do it long way. Okay, let's try one. Y equals x squared plus 2x. At x equals 0. So we want to find out what's happening at 0, or if we go a little further than 0. This is your a. The limit is b approaches 0. F of b minus f of 0 over b minus 0. Now, if you wanted to plug in right here, you could. You don't have to write this part. You could skip it and go to the next. We could start with this step. First one's f of b, so you just plug b wherever x is. B squared plus 2b. This would be f of b minus f of 0, plugging in 0. 0 squared plus 2 times 0. All over b minus 0 is b. Any questions so far? Okay. Now notice if we calculate this, 0 squared plus 2 times 0 is just 0. So this part drops out. So we can just drop that out because it's 0. If there was a number there, we would keep it. So this drops out. There's nothing in front to distribute, so it's just b squared plus 2b over b. Any questions so far? Okay, if we plug the 0 in right now, we'd have 0 over 0 because, well, we know we definitely have 0 in the denominator. So we have to try and simplify this. One way of simplifying is to factor. One mistake would be to just cancel these two b's. In this case, because you're plugging in 0, you're still going to get the same answer, but not in any other case. So you have to remember, if you have more than one term on top and bottom, you cannot just cancel it. So we'd have to factor the b out first. And then these two b's will cancel. Now that that b that was giving us a 0 in the denominator is gone, we can plug the 0 in. Now I'll show you another way of simplifying this part. But any questions? The other way we could do that is we have 3 terms with a b in it. We can divide each of them by b. You have to do it to all 3 terms. B squared divided by b is b. Here the b's cancel, plus 2. And b over b is 1, which is b plus 2. So either way, factor and then simplify, or divide it into every term. Any questions on that one? Positive. Let's try another one. F of x equals 1 minus x squared at x equals a negative 1. So let's find the instantaneous rate of change for this function at x equals a negative 1. This is your a. And the limit as b approaches a, which is, I'm just going to fill it in, negative 1. Is f of b minus f of negative 1 over b minus a negative 1. So I'm going to plug in b, and then I'm going to plug in negative 1. F of b would be 1 minus b squared minus f of negative 1 is 1 minus a negative 1 squared all over b plus 1. Any questions so far? So here we have 1 minus b squared. When you calculate this, you need to be careful. This exponent is first, so negative 1 squared is a positive 1, and this makes it a negative 1. So 1 minus 1, this is 0 again. All over b plus 1. Any questions so far? Now you need to use your algebra skills and simplify. Because notice if we plug a negative 1 in here, we're getting a 0 in the bottom. So if we can't simplify this, then the limit doesn't exist. Also, if you plug in negative 1 on top, you have 0 over 0. But this top is perfect squares. This will factor. One minus b squared is 1 minus b times 1 plus b. Any questions? Now these two are the same because the ones are both positive and the b's are both positive. We can cancel this. We have the limit as b approaches a -1 of 1 minus b. And then you plug your value in. So you don't want to try plugging it in until you get rid of this original part. Otherwise, you're going to have 0 over 0. One minus a -1 gives us 2. Any questions on that? So at -1, if we want one more unit, the y value increases by 2. Any questions? Okay. Try a story problem. Suppose that the total profit in hundreds of dollars is from selling X items is given by P of X equals 2x squared minus 5x plus 6. So there's a few parts to this one. Find the average rate of change from 2 to 4. So the first thing you want to do is find the average rate of change between two values. Between two values is your slope. F of B minus F of A, or you could use P if you want, over B minus A. This is our A, this is our B. So it's going to be the profit at 4 minus the profit at 2 over 4 minus 2. Now we could plug this in here. You would go under y equals, clear what's there, 2x squared minus 5x plus 6. Then we can go to our table, delete what's there, and put a 4 and a 2, because that's what we want, 4 and 2. So P of 4 is 18, and P of 2 is 4. Eighteen minus 4 is 14 over 2, which is 7. So if we're selling 2 items and we decide to go to 4 items and sell them, we increase, because it's positive 7, we increase profit by $700, because profit is in hundreds of dollars. So instead of 7, it's 700. So it tells you if you're already selling 2, if you sell 4 items instead of 2, you increase your profit by $700. Any questions on that? Find and interpret the instantaneous rate of change. When x equals 2. Now this one's at one value. When it's at 1, that we're using the limit. The limit as b approaches a, and 2 is our a, f of b minus f of 2 over b minus 2. So f of b. F of b, we plug it into our equation all the way up here, so that it's 2b squared minus 5b plus 6, all of, minus. Let me move it down. Two b squared minus 5b plus 6 minus, and now we plug in a 2. 2 times 2 squared minus 5 times 2 plus 6 all over b minus 2. Now we need to calculate this. Two times 2 is 4, times 2 is 8, minus 10, plus 6, it's 14, minus 10. So 14 minus 10 is 4. 2 times 2 is 4. Just want to make sure I didn't make a mistake. Okay. Any questions so far? So I calculated this and I got 4. So yeah, I got a positive 4, but then we want to subtract. So we're subtracting a positive 4. Any questions so far? So make sure this is a minus because of this subtraction. We need to combine our like terms, the 6 and the minus 4. We still need to get this reduced, which means we need to factor the top. Now, when you know part of the factor, trial and error is not so bad, but you could also factor it by making the x in factor. We know this is giving us our 0. 2 minus 2 is 0. So we know we have to have the factor in the top. You can use trial and error. B times what will get me the first term? 2b squared. Well, I need a 2 and a b. 2b times b gives me 2b squared. Then look at the negative 2. What times a negative 2 gives me a positive 2? A negative 1. Negative 2 times negative 1 gives me a positive 2. The middle is just going to fall into place. To do it the other way, when we were factoring, we did this. You multiply, 2 times 2 is 4. So we need to multiply and get a 4 and add to get the middle number, which is a negative 5. And that would be negative 1 times negative 4. Multiplying, we get the positive 4. Adding, we get the negative 5. So negative 1 and negative 4. And then you divide by what's in front. Our variable's a b. So the first one, 2b minus 1, right there. 2b minus 1. This one reduces to negative 2 over 1, dividing top and bottom by 2. Put your b in the bottom, 1b minus 2. B minus 2. So whether you use this, you can use factor by grouping, trial and error, it will get you there. The b minus 2's cancel. And leave the limit as b approaches 2 of 2b minus 1. Once you get rid of the part that's making the 0 in the denominator, you can plug in your number. And get 3. Any questions on the limit part? Now what this means is we plugged in a 2. When selling 2 items, if sell one more, or you could put the third item, one more, the profit increases by $300. So if we're already selling 2, if we sell a third one, we will increase our profit by $300. I'm just saying if you go one more, where the other one was saying we went between 2 numbers if we increased, but this tells you at that instant, if you're doing 2, if you went one more, how much would you make? And again, remember this is profit, which was in hundreds, so I multiplied it by 100. Any questions on that? Another thing to note, because it also asks you for part D, says find the marginal profit, but marginal, and this is more in the next section, but marginal is the same as instantaneous. So if you're looking for marginal of something, you're looking for instantaneous. But any questions? Okay, if there is no questions,